Okay, now let's take a look at this example. We want to write the integral of this function f of r and theta equals r cosine theta on this bounded region R. You can see here. Simply speaking, the region R is bounded between these two curves. One is circle, you can see, and there's a unit circle centered at origin. And you know that the polar equation of this circle is, okay, let's call it R2. R2 equals 1. The other one is this cardioid, okay, and the equation of this cardioid R1, the equation of this cardioid is R1 equals 1 minus cosine theta. And look at here to describe or cover the region R using R and theta or in polar coordinate system. So you can see theta must move from here to here. Okay, you can see actually the lower and upper limit for for theta are given. Theta goes from minus pi over 2 to pi over 2. But let me ask you something. If these two, minus pi over 2 and pi over 2, which are actually the intersection points of the circle and cardioid, are not given, how do you find these two? How do you find minus pi over 2 and pi over 2? So to find them, if they are not given, you have to solve this system. Okay, it means you have to put R1 equals R2. So we have 1 minus cosine theta equals 1. So from here we get minus cosine theta equals 0, and then from here we get cosine theta equals 0. So this equation has many answers, but the answers that we are looking for are, so you agree with me, the answers that we are looking for are this, minus pi over 2 and pi over 2. So you agree with me, like this, pi over 2 equals 0. So this is my point. If lower limit and upper limit for theta are not given, you have to solve this system to find them. You can see here. So theta is from minus pi over 2 to pi over 2. Okay. And now for R, look at here, you agree with me in this region R. So the inner radius is the cardioid. Outer radius is the circle. So look at here, R to cover the region R. R is from R1, the cardioid, 1 minus cosine theta, to R2, 1, the circle. So we can see here the integral is set up correctly here. But let me write it one more time. Here, let me erase this. Okay, so let's continue. You can see the answer is given, but I'm going to repeat. There is no harm. So this equals, okay. You can see here, okay, this is for theta, this is for R. So R is from the inner radius, 1 minus cosine theta to outer radius, which is 1, and theta is from minus pi over 2 theta is from minus pi over 2 to pi over 2 here, pi over 2. And what is f? F is r cosine theta, right? F is r cosine theta. This is our f. And what is dA? dA is r dr d theta. Correct or not? So this equals, maybe we can write here, this equals, so the integral, okay, look at here, r times r, r squared. So we have r squared cosine theta r squared cosine theta dr d theta, and here for theta from minus pi over 2 to pi over 2, and here 1 for r, 1 minus cosine theta to 1. Okay, you can see the same answer here. You can see here r2 cosine theta dr d theta. Yes, here r from 1 minus cosine theta to 1. Theta is from minus pi over 2 to pi over 2. You can see here. Okay, now look at here. We can go ahead and we calculate this integral. However, it is not, they did not ask this. But I have done this. We can go ahead. First, we integrate with respect to r, then with respect to theta. But the calculation is quite huge. So I'm going to give you another example similar to this in the next file. Then we can calculate the integral till the end. So the main point of this example was to set up the integral correctly.